The size of a transfer station depends on the amount of waste going through it. Buildings will typically be at least 12 metres high to be tall enough to allow the vehicles and equipment to operate safely. The size and appearance of this type of facility, together with the transport requirements, mean that they can integrate well with existing industrial estates. The key planning issues associated with transfer stations include traffic, visual impact, odour, noise, and litter. Again, these issues can be overcome if the facility is positioned, designed, and managed in the right way. Mechanical separation plants are typically called materials recovery facilities or materials recycling facilities, or MRFs for short. An MRF is used for sorting, storing and bulking up materials that can be recycled. In planning terms, they have a lot in common with transfer stations, but involve some form of segregation or processing of a range of materials. MRFs can be designed to handle source-separated materials, such as those collected from curbside boxes or general waste that's been put into bins. Various sorting processes, such as hand-picking, mechanical sorting and magnetic separation, are used to divide the waste into the various recyclables. There is no such thing as a typical mechanical separation plant. The nature of the process and scale of operation is tailored to suit the local waste strategy and the particular needs of the local authority. MRFs, like transfer stations, can be quite large buildings, typically up to about 12 metres high, and have vehicles delivering waste and removing the segregated materials throughout the day. They may be relatively simple operations for bulking the materials collected by curbside, or may involve processing machinery for separating recyclables. Mechanical sorting processes can be combined with treatment systems such as composting, anaerobic digestion, or autoclaving. When combined, such as here in South London, this integrated approach is often referred to as mechanical biological treatment, or MBT for short. As with transfer stations, the location of MRFs needs some careful thought. They can generate a lot of traffic, mostly HGVs. Good access to the primary road network helps to maximise their efficiency. The nature of the processes involved at MRFs also means that they fit well with existing industrial estates or certain business uses. The key planning issues associated with MRFs include noise, visual impact, odour, traffic, and litter. As with transfer stations, these issues can be overcome if the facility is positioned and managed in the right way. There are two main biological processes that are used in waste management: composting and anaerobic digestion. These deal with the organic fraction of waste such as food and garden waste and can take several forms. Ultimately, they produce materials which can be used as a soil improver and fertiliser, and some processes can produce energy in the form of biogas. There are two main options for composting: windrows or in-vessel systems. Windrows are large mounds of compostable material placed in strips which are turned regularly to speed up the process. In essence, this approach is a scaled-up version of composting in your back garden. In-vessel systems are more complex and allow a greater degree of control. This allows more types of material to be fed into the process, including those covered by the Animal Byproducts Regulations. Anaerobic digestion, as here in Ludlow, also takes the organic fraction of waste. But unlike composting, the degradation takes place without oxygen and in a more controlled environment. The control over the process means that the resulting biogas can be captured and burnt to produce energy. The liquid and solid digestate that is produced by anaerobic digestion can also be used as a soil conditioner. Biological treatment facilities can be positioned in a wide range of locations. They may be larger and centralised, provided on farms, or may be smaller community-scale facilities. Biological treatment facilities can take a number of forms depending on the option taken. Some can be completely open, whereas others would be housed within a building. Clearly, they can also generate traffic, as the material to be composted needs to be brought to the facility and the resulting compost needs to be removed. The key planning issues associated with biological treatment facilities include odour, bioaerosols and traffic. Bioaerosol is the collective name for the bacteria and pathogens that can be released by the various biological treatment options. This means that the facility may need to be positioned carefully in relation to the community or use other options such as negative pressure to control the emissions from the process. Thermal treatment plants have many different names. Energy from waste plants, waste to energy plants, even resource recovery centres. There are also different technologies, from large mass burn or traditional incinerators to emerging gasification and pyrolysis plants. Thermal treatment plants are often seen as the most controversial option, but they frequently form a core part of an integrated waste management system, allowing energy to be recovered from the waste. This technology is used widely throughout Europe and forms a tried and tested part of the strategy for managing waste. Compared with incinerators of the 1960s and 70s, strict pollution controls means that modern facilities are now much cleaner than they used to be, and it has been scientifically proven that the health risks are negligible. Thermal treatment plants fit with the recovery part of the waste hierarchy. They are used to recover what we can from the waste that is otherwise destined for landfill. This means that when the waste is burned, the energy generated can be used beneficially. Electricity can be generated using a steam turbine. Alternatively, the steam or hot water produced could be used in neighbouring industrial processes or surrounding buildings. An example of this in the UK is the Sheffield Energy Recovery Facility. It not only produces electricity, but is connected to a 43-kilometre network of pipes forming a district heating network. Another example in continental Europe is the Spittelau facility in Vienna, which contributes to a vast district heating network covering a third of the city.
If the local authority is considering energy from waste as part of its technology solution, then there's great potential for combined heat and power, or CHP. CHP can provide real benefits to the local community, but it will also require some vision on the part of members and officers, because sometimes it'll cost a little bit more, might take a little bit longer, but it requires buy-in from a wider group of stakeholders. CHP can be provided for district heating, for industry, or even for leisure facilities such as swimming pools. It can also provide benefits to the community and the local authority in terms of carbon savings and reducing the carbon footprint of the authority.
Thermal treatment produces solid residues. The bottom ash that results from the process can be used in various ways, for example being mixed with aggregate and used in road construction. So why is thermal treatment so controversial? A lot of this is down to misconceptions and misinformation. Incineration is always high profile, it'll hit the headlines and is a hot political topic. Air pollution is by far the biggest perceived concern, and a lot of work has been undertaken to look into the potential health risks. The other thing that is usually discussed at length when incineration is mentioned is that they are waste-hungry machines. Yes, it is important that the capacity of a thermal treatment plant is sized appropriately, but other European countries have shown that incineration can work in conjunction with high levels of recycling. The various planning issues highlighted for other facilities also apply to thermal treatment plants. But the nature of the process, together with the potential scale of the buildings, means that the key issues specific to these facilities are air emissions and potential visual impact. A lot of work has been undertaken to establish the risks associated with air emissions from thermal treatment facilities. The abatement techniques used to clean the gas emissions from such plants are advanced and have been tried and tested. But it would still be normal to undertake sophisticated modelling exercises to establish the likely impact. With landscape and visual issues, it is more subjective. Thermal treatment plants are likely to be big buildings and will also have a chimney to get the right dispersion of emissions. Therefore, these are buildings that tend to stand out, so choosing the right location is important. The design of such buildings should also be considered at an early stage, as the creation of a landmark building can be a desirable option. Landfill should not be forgotten. It still forms an important part of the waste management hierarchy, as there will always be some residual waste that needs to be disposed of. For example, some of the management options produce materials that may have to be landfilled. But this should be viewed as a last resort. It's important to take an integrated approach to waste management so that we can make the most of the waste that we all produce.